Welcome back, students. Today in this session we are going to solve some of the questions from exercise 8.1 and 8.2. Earlier in our video we have learned about properties of quadrilaterals. So to better understand those properties, we are going to solve these questions from exercise 8.1 and 8.2. So starting from exercise 8.1, question number 2. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So, solution. Given a quadrilateral, a parallelogram ABCD, in which both the diagonals are equal. So this is the parallelogram ABCD, and the diagonal AC is equal to BD. AC is equal to BD. So we are to prove this parallelogram is a rectangle if this diagonal AC and BD are of equal length. But to prove this, if we are able to prove one of the angles of the parallelogram, there is either angle A, B, or C, or D is 90 degrees, then we can say that the given parallelogram is a rectangle. So first let us write down the given information. So given a parallelogram ABCD in which the diagonals AC is equal to BD. Then to prove ABCD is a rectangle. Now proof. Let us consider the two triangles, triangle ABC, and triangle BAD. So in triangle ABC and triangle BAD, we get AB equal to AB. That is, this side is common to both the triangles. Then side AC is equal to side BD. That is, these are the diagonals of the parallelogram which are of equivalent length. And then the side BC equal to AD. Why? Because these are the opposite angles of the given parallelogram. So opposite sides. So these two sides are the opposite sides of the given parallelogram, so they are of equivalent length. So by SS congruence theorem, these two triangles are congruent. Therefore, triangle ABC is congruent to triangle BAD. Now, since these two triangles are congruent to each other, we can say that angle ABC is equal to angle BAD. Angle ABC is equal to angle BAD. These are the corresponding parts of the congruent triangle. Now, angle ABC plus angle BAD is equal to 180 degrees. Why? Because these are the adjacent angles of a parallelogram. Angle ABC and angle BAD is the sum of these two angles is equal to 180 degrees. Why? Because this is the adjacent angles of the parallelogram. Adjacent angles. of the given parallelogram. This implies angle ABC plus angle ABC. That is, angle BAD is equal to angle ABC. Earlier we have proved this. So instead of angle BAD, we write angle ABC equal to 180 degree. Implies twice angle ABC equal to 180 degree. This implies angle ABC is equal to 90 degree. Since angle ABC is 90 degree, that is, one of the angles of the parallelogram is 90 degree, so we can say that the given parallelogram is a rectangle. So therefore angle ABC is equal to angle, that is, angle BAD is also equal to angle ABC. So angle BAD equal to 90 degree. Both angles are of 90 degree. So we can easily say that the given parallelogram is a rectangle. That is, ABCD is a parallelogram in which one of the angle in which one of the angle is 90 degree. Therefore, hence the given parallelogram ABCD is a rectangle. Hence on. Next exercise 8.1, question number 9. In parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equal to BQ. Then show that triangle APD is congruent to triangle CQB, and also AP is equal to CQ. Triangle AQB is congruent to triangle CDP. And in Roman number 4, we have to show that AQ is equal to CP, and last, Roman number 5, AP CQ is a parallelogram. So question number 9, solution. Let us first write down the given information. Given ABCD is a parallelogram. Is a parallelogram in which P and Q are 2 points on diagonal BD such that BQ is equal to DP. To prove Roman number 1, triangle APD is congruent to triangle CQB, and Roman number 2, AP is equal to CQ. Roman number 3, triangle AQB is congruent to triangle CPD. Roman number 4, AQ is equal to CP. And last, Roman number 5, we have to prove APCQ is a parallelogram. APCQ is a parallelogram. Let us first prove triangle APD is congruent to triangle CQB. So prove in triangle APD and triangle CQB, side PD is equal to QB, this is given, and then side BC, let us first say side AD is equal to side CB. That is, these are the opposite sides of the parallelogram, opposite sides. And then angle ADP is equal to angle CBQ. This is the alternate angles. Now therefore triangle APD is congruent to triangle CQB by SAS congruence rule. Hence proof that triangle APD and triangle CQB are congruent to each other. Now, since these two triangles are congruent to each other, we can easily say that the side AP is equal to side CQ. So we have proved Roman number 1 and Roman number 2. Now let us try to prove Roman number 3. That is triangle AQB and triangle CPD are congruent to each other. For Roman number 3, in triangle AQB and triangle CPD, the side AB is equal to side CD. That is, these are the opposite sides of the quadrilateral. Opposite sides. And then side BQ is equal to side DP. And the measurement angle ABQ is equal to measurement angle CDP. This is the alternate angles. Now by SAS congruence rule, these two triangles are congruent to each other. That is, triangle AQB is congruent to triangle CPD. And also from the congruence rule, this is by SAS congruence rule. And also from this, we can say that the side AQ is equal to side CP. This is the corresponding part of the congruence triangle. So the last part, that is APCQ, is a parallelogram. Now let us try to prove the last part. Roman number 5. In quadrilateral APCQ, this opposite sides, that is side AP is equal to side CQ. Side AP is equal to side CQ, and also the opposite sides AQ is equal to CP. AQ is equal to CP. So since the opposite sides are equal in length, the quadrilateral APCQ is a parallelogram. Since the opposite sides are equivalent length, opposite sides are equivalent length, quadrilateral APCQ is a parallelogram. The opposite pairs of sides are equivalent length. So the given quadrilateral APCQ is a parallelogram. Next, exercise 8.1, question number 12. ABCD is a trapezium in which AB is parallel to CD and AD equal to BC. Then show that angle A equal to angle B, angle C equal to angle D, triangle ABC is congruent to triangle BAD, and then the diagonal AC is equal to the diagonal BD. So exercise 8.1, question number 12, solution. Let us first write down the given information. Given ABCD is a trapezium. ABCD is a trapezium in which AB is parallel to CD and AD side AD is equal to side BC. To prove, formula number 1, angle A is equal to angle B. Formula number 2, angle C is equal to angle D. Formula number 3, triangle ABC is congruent to triangle BAD. And last, Roman number 4, diagonal AC is equal to diagonal BD. There is diagonal AC is equal to diagonal BD. Construction, we need construction. Let us extend AB, and a line is drawn through C parallel to DA intersecting AB produce at E. So we extend AB and a line is drawn parallel to DA intersecting the extent of AB at the point E. Proof. It is given that AB is parallel to CD, that is AB is parallel to CD, that is AE is also parallel to DC. AE is also parallel to CD and AD is parallel to CE. This is by construction. By construction, AD is parallel to CE. Therefore, AD CE is a parallelogram. Why? Because the opposite sides are parallel to each other. That is, side AD is parallel to side CE and side AE is parallel to side CD. So ADCE is a parallelogram. Now, since ADCE is a parallelogram, side AD is equal to side CE. That is, it is the opposite sides of the parallelogram. This is the opposite sides of the parallelogram, and also AD this side AD is equal to side BC. Side AD is equal to side BC. There is given information. So from this two, we can say that side BC is equal to side C. Side BC is equal to side C. Now, in triangle CBE, these two sides, side BC and side CE, are equal in measure. Therefore, angle CBE, this angle, and angle E will be of equal measure. So, therefore, angle E is equal to angle CBE. CBE. Next, if you observe angle B, there is this angle B, plus angle CBE. CBE is equal to 180 degree. That is, they form a linear. This implies angle B plus CBE. That is, angle CBE is equal to angle E. So instead of CBE, we can write angle E. So angle B plus angle E equal to 180 degree. And also angle A plus angle A, this angle, plus angle E is equal to 180 degree. Why? Because it is the adjacent angles of the parallelogram. Which parallelogram? Parallelogram ADCE. So, and again from this two, we can say that angle B plus angle E equal to angle A plus angle E. There is this sum of these two angles are of the same measure, so we can say angle B plus angle E equal to angle A plus angle E. From this, we can conclude that angle A is equal to angle B. In both sides of the equation, we have the same angle E, so these two will cancel out, and the remaining angle A is equal to angle B. Hence, proof. So we have proved the first part, that is angle A is equal to angle B. Now let us come to the second part, that is angle C is equal to angle D. So we have to prove angle C is equal to angle D. To prove, let us consider angle A plus angle D. That is, angle A plus angle D is equal to 180 degree. Why? Because the side AB is parallel to CD, and these two angles form the adjacent interior angle. So this, the measure of these two angles will be 180 degree, and also angle B plus angle C equal to 180 degree. Same reason, from these two we can say that therefore angle A plus angle D equal to angle B plus angle C. This implies, we already know that angle A is equal to angle B, so these two will cancel out each other, and from this we can conclude that angle C is equal to angle D. Hence, proof. So now let us come to the third part, that is triangle ABC is congruent to triangle BAD. So in triangle ABC and triangle BAD, side AD is equal to side BC. Side AD is equal to side BC. This is given information. And angle A is equal to angle B. We have earlier proved this. And side AB is equal to side AB. There is common to both the triangles. So triangle ABC is congruent to triangle BAD by SAS congruence rule. By SAS congruence rule, these two triangles ABC and triangle BAD are congruent to each other. Now For Roman number 4, there is the diagonal AC and the diagonal BD are of equivalent length. We can easily derive from the proof of the third part, it is triangle ABC and triangle BAD are congruent to each other. We can easily say that side AC is equal to side BD. Why? Because these are the corresponding parts of the corresponding triangle. So hence shown. Next, exercise 8.2, question number 1. ABCD is a quadrilateral in which PQ, R, and S are the midpoints of the sides AB, BC, CD, and DA. AC is a diagonal so that Roman number 1, SR is parallel to AC and SR is equal to half of AC. Roman number 2, PQ equal to SR, and Roman number 3, we are to prove PQ RS is a parallelogram. So question number 1, solution. Let us first write down the given information. There is given ABCD is a quadrilateral. ABCD is a quadrilateral in which PQRS are the midpoints of side AB, BC, CD, and AD respectively. And then AC is the diagonal of the quadrilateral ABCD. AC is a diagonal. To prove, there is what we are going to prove. Roman number 1, SR is parallel to the diagonal AC and SR is equal to half of AC. Roman number 2, PQ equal to SR. PQ equal to SR, and Roman number 3, PQRS is a parallelogram. PQRS is a parallelogram. Now proof. Roman number 1. For Roman number 1, that is we are going to prove SR is parallel to the diagonal AC and SR is half of AC. So if you closely observe the figure in triangle ADC, S and R, there is a point S and R are the midpoints of the sides, are the midpoints of the side AD and BC. So the line drawn joining the midpoints of the two sides of a triangle will be parallel to the third side. Here the third side is AC, which is also known as the midpoint theorem. So according to the midpoint theorem, SR will be parallel to this third side AC, and also SR will be equal to half of AC. This is according to midpoint theorem. Line joining the midpoints of two sides of a triangle is parallel to the third side of the triangle, and it is also equal to half of the third side. So SR will be parallel to the diagonal AC and SR will be equal to half of AC. Similarly, To prove Roman number 2, that is PQ equal to SR, similar is the same thing will be proceed as in triangle ABC. In triangle ABC, P and Q are the midpoints of the side AB and BC. These are the two sides of the triangle ABC. So the line joining these midpoints will be parallel to the third side, that is AC. So similarly, PQ will be parallel to AC and PQ will be equal to half of AC. So from these two, there is SR equal to half of AC and PQ equal to half of AC. We can say that PQ is equal to SR. Therefore, this is also midpoint theorem. So from these two, PQ is equal to SR. For the third part, that is PQRS is a parallelogram. It is observed that from 1 and 2, from the earlier proof of Roman number 1 and 2, SR is parallel to the side diagonal AC, and also PQ is parallel to the diagonal AC. So from these two, we can conclude that SR is parallel to PQ. SR is parallel to PQ, and also PQ is equal to SR. So the opposite sides SR and PQ of the quadrilateral PQRS is parallel to each other, and also they are equal in length. So the given quadrilateral PQRS is a parallelogram. Therefore, PQRS is a parallelogram. Why? Because one pair of the opposite sides, that is SR and PQ, are parallel to each other and they are of equivalent length. So the quadrilateral PQRS is a parallelogram. Hence, proof. Next, exercise 8.2, question number 7. ABC is a triangle. Right angle at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. So that's Roman number 1. D is the midpoint of AC. Roman number 2, MD perpendicular to AC. And Roman number 3, CM equal to MA equal to half of AB. So solution to exercise 8.2, question number 7. It is given that ABC is a right angle at C, and M is the midpoint of AB, side AB, and DM is perpendicular parallel to BC. Let us first draw the figure. So triangle ABC is a right angle triangle, at C, and M is the midpoint of side AB, that is hypotenuse AB. M is the midpoint of the side AB, and DM is parallel to BC. DM is parallel to BC. Now we are going to prove D is the midpoint of side AC, and MD is perpendicular to AC, and CM, that is this line, CM is equal to MA is equal to half of AB. So let us try to prove the first one, that is D is the midpoint of AC. So in triangle ABC, triangle ABC. M is the midpoint. M is the midpoint of side AB, and MD, that is DM is parallel to BC. Now, if you recall the converse of the midpoint theorem, says the line drawn through the midpoint of one side of a triangle parallel to the another side bisects the third side. So, according to the converse of the midpoint theorem, this point D bisects the third side AC, that is, D is the midpoint of AC. Therefore, D is the midpoint of AC. Midpoint of AC. This is converse of midpoint theorem. Now moving on to the next proof, that is Roman number 2. We have to prove MD is perpendicular to AC. MD is perpendicular to AC. That is, if we can prove that the angle MDC is equal to 90 degree, then we can easily say that MD is perpendicular to the side AC. For that, we have earlier known that DM is parallel to BC. So, since DM is parallel to BC, measurement angle MDC plus measurement angle BCA equal to 180 degree. There is these two lines DM and BC are parallel to each other, then the measurement angle of these two, the sum of these two angles will be equal to 180 degree, because these are the adjacent interior angles of the two parallel lines. So according to this, implies measurement angle MDC plus, we already know that BCA is measurement angle BCA is 90 degree, because it is right angle at C for the triangle ABC. This implies 180 degree. This implies measurement angle MDC is equal to 90 degree. So the measurement angle MDC is equal to 90 degree. Therefore, we can say that MD or DM is perpendicular to AC. Now for the third part, there is CM equal to MA equal to half of AB. So let us consider two triangles. There is triangle ADM, and triangle CDM. AD is equal to DC. Why? Because D is the midpoint of AC. Midpoint of AC. So AD is equal to DC. And then measurement angle ADM is equal to measurement angle CDM. It's being 90 degree. And also the side DM is equal to DM. That is common to both the triangles. Therefore, now by SAS congruence theorem, triangle ADM is congruent to triangle CDM by SAS congruence theorem. If these two triangles are congruent to each other, then we can say that the side CM CM is equal to the side AM. That is, these two are the corresponding parts of the corresponding congruent triangles. So CM is equal to AM, but we know that AM is equal to half of AB. Why? Because M is the midpoint of the side AB. So therefore CM equal to AM can be written as MA equal to half of AB. So from these two we can conclude that CM is equal to MA is equal to half of AB. Hence